Root module versus child module. A child module cannot directly read resources declared only in the root module. Terraform treats each module as a separate scope with its own symbol table. By separating scopes, Terraform prevents hidden dependencies between unrelated files. A child module only receives values passed through the input variables. A child module only returns values through outputs. This is why AWS VPC.main.id inside the root module is not visible inside a child module unless the root passes that value into the module call. The planned outcome is deterministic because Terraform builds dependencies from declared inputs and outputs, not from file proximity or folder nesting. The root module is the assembly layer for the configuration. The root module selects providers, configures provider instances, and connects child modules together. A child module defines reusable infrastructure logic, not the overall deployment shape. By placing wiring in the root module, we keep reusable logic separate from environment-specific decisions. Terraform state records module paths, so the root appears at the top level and child resources appear under addresses like module.childidentity.aws SSN That address path is the proof that a child module is a nested scope, not a second root. Changing module wiring in the root can change graph edges without modifying the child module source. A module interface is made from input variables and outputs. Terraform uses that interface to calculate dependency edges across module boundaries. When the root passes AWS VPC.main.id into a child input, Terraform creates a graph edge from the VPC resource to the child module resource that consumes the value. That edge causes correct create order during apply and correct unknown propagation during plan. Without an explicit interface, Terraform has no legal path to move data across the boundary. This is why module design is not just code organization. Module design changes graph visibility, state addresses, and data flow. Child modules can inherit provider configurations from the root module, but provider inheritance does not merge resource scope. The provider gives the child module a way to talk to AWS. The provider does not give the child permission to reference root resources by name. This distinction matters because many beginners confuse provider availability with data visibility. A child module can create AWS resources with the inherited provider and still remain isolated from root resources symbols. Terraform keeps provider configuration flows separate from expression scope resolution. That separation keeps planning predictable when many modules share the same AWS account and region. On a submarine, compartments are useful because they force routing through controlled boundaries. A flooding casualty in one compartment does not get permission to spread just because another compartment shares the same ship. Terraform modules work the same way. Shared provider access is like shared ship power. It lets multiple compartments function. It does not remove the watertight doors. The highest operational risk appears when engineers assume a child module can freely reach into the root because both use the same AWS provider. That false assumption causes bad module design, hidden coupling attempts, and confusing refactors later.